Welcome everybody. Thanks for gathering with me today. Just going to go through this topic really quick. A galactic rearview mirror, the science of our shifting skies. It's easy to get into a rhythm with our observing seasons. Some of you will remember what this is. This is a planisphere, and it's how we used to be able to, long before we had Sky Safari or Stellarium or anything like that, we used to have these. They have the constellations on them, and you would simply adjust the time for, like right now, it is 5:18 in March. So I would go to 5, and I would find March, and we are about on the 5th. So there's one that called the 6th. So I just kind of line it up there, and those are the constellations that I can actually see. Now, what I can do is I can adjust that each day for the month of, and I'm actually going to move it over to 10 p.m. and bring that over to March. And I'm going to put it about new moon time, so right around the 16th. And here, as I look at it, you probably aren't going to see that because of the glare and the reflection from the light. But I'm seeing Ursa Major's rising really, really good there in the north, in the, turn it the right way. Leo's up. It's going to be right in the northeast sky. You have Virgo coming up. Corvus is coming up. Bootes is rising. You're beginning to see Hercules come in from the east-northeast, just on the horizon. Cassiopeia is low in the northwest. In the west, you have Taurus fading, you have Gemini fading, and you have Orion fading. I can turn that each night now in March, and I can see just how, like going from March 16th to April 15th for 10 p.m., definitely by now, Aldebaran's at 10 o'clock at night. It's just about underneath the western horizon. Gemini is falling fast. Orion is going out of the picture. Sirius, Canis Major's out of the picture. And of course, the spring constellations, they're there. So anyway, now we basically use an app like what I have here with Sky Safari, and we can adjust the dates and do all that. Works great, okay? So while we wait for summer Milky Way to rise, or those crispy winter nights when Orion's going to dominate the meridian, we've always been taught that the stars we see are strictly governed by where the Earth is in its orbit till now. Research has been looking at the orbital dynamics of stars within our own galactic neighborhood. They've been doing this for a long time. This is nothing really new. And it turns out that the fixed nature of our constellations is a bit more fluid than some probably really realize. You can see in the image up above, you can see Crux, and you can see Crux when it was about 30 BC, where it is today, where it's going to be in about 50,000, then 100,000 years. You can see Leo is going to transform from the lion into, I don't know what it's going to be called then, and Cassiopeia was definitely not at the W it was today, and it's going to start to lose its W shape, and in about 100,000 years, it's going to look a lot different. So, we know that as the Earth orbits the Sun, our night side points toward different regions of the galaxy. That's why we get Scorpius in July, we get Gemini in January, but this new research suggests that the stellar proper motion, the actual movement of stars through space, is starting to measurably interact with our seasonal perspective in ways we haven't fully accounted for in the long-term models. The article that I was looking at points out that while the changes isn't something you'll notice or I'll notice tonight in our telescopes or images or just looking visually at the night sky, or tomorrow or next month or even next year, the cumulative effect of these stellar velocities is blurring the lines of our traditional seasonal markers. Why does it matter for us? Well, for those of us who spend our nights behind the eyepiece of a big Dob or a refractor or imaging, we tend to think of the deep sky kind of as a static map. Basically, it is in our lifetimes. We either use a go-to method or star hop based on fixed assumptions of constellations and stars. But this study is a great reminder that we're living in a high-velocity neighborhood. that in terms of stellar time, the stars and constellations, the stars are moving on their own trajectory, and thus the constellations, not in a human life, but in a galactic time period, are going to change and adapt. What I found most interesting about this is how it highlights the narrow window of human history. We've caught a galaxy at a specific time frame in its long movie. Same thing with a star. The constellations I'm sketching tonight, or you're observing or imaging, are a temporary arrangement. Here again, you can see there's the Big Dipper in 50,000 BCE. Then again, 2000. Here's the Big Dipper as we see it today. 50,000 years from now, it's going to become a little elongated dipper. And by 100,000 BC, well, it's going to look not like a Big Dipper. It's going to look like almost like a little handheld dust vac from the day. You can see Orion, how it's changed. Really peak hid there. The bow wasn't always there. 2000, it looks like Orion of today. 50. So in another 48,000 years, Orion's going to change drastically, and in another 98,000 years, you can see Orion won't even look like it does today. So it makes you appreciate that as those photons are hitting the mirror and your eyes even more, we're just not looking at distant suns. We're looking at dynamic swirling systems where the very definition of a winter star is eventually going to expire. And you know, at some point, somewhere probably like Orion here, Betelgeuse here will probably go supernova and fade out of the constellation. So next time you're out under dark skies, take a look at the familiar seasonal star like Vega or Sirius, Betelgeuse and Rigel, Altair, Deneb. Look for your fall ones in Cassiopeia, in Pegasus, in Perseus, and think about the fact that they aren't just sitting there waiting for the Earth to turn. They're on their own high-speed journeys. And the map we use is constantly, slowly beginning to be rewritten. And our descendants 198,000 years from now are going to see the sky a lot different than how we see it. Anyway, just some kind of a cool thought to think about if you haven't thought about that for a while. Hope you've enjoyed this. Thanks for joining me. We'll catch you next time.